In this video, we are going to see some of the use cases of the stack, like where are stacks commonly used. In the real world, we have already discussed earlier, like you can see a stack of plates, books, or like even your Pringle chips that you have in supermarkets, or the stack of books that you see right here. Now, but where do we see this in like applications of computers? So one of the common use case is the function call stack. We are going to see some of these in more detail in the next few slides. But let's say if you are calling one function from another to another, we know like computers memory is divided into something called stack and heap, and stacks keeps trace of the various function calls. Stacks are also used to evaluate expressions, like they are very popular data structures in designing compilers, because you always like evaluate expressions using compilers, using stacks. They are also used in backtracking, or like let's say we are trying to solve a maze, they are very popularly used. Or let's say if you are trying to program a robot that's going through some path, they are again used in such scenarios. We are going to see some applications of backtracking in the later half of the course when we go into in detail into greedy algorithms. They are also used to check whether an expression has balanced parentheses, which is, let's say if we have some numbers, like is this valid or not? Like if we have some parentheses, like we cannot have something like three of these because we don't have an opening and closing bracket. Another common application is the undo button. So whenever we press like Control Z, everything is like we are going to the previous state, and whenever we want to go to the last previous state, we use a stack. And the last one is the browser back button, which is like if you try to go back in the Google Chrome browser or any other browser, it's probably using a stack behind the scenes. So this is an example of the call stack, which is you basically have these different functions which call each other. So initially, main will be allocated a space in the function stack or in the call stack. This is a program counter. So those of you who have taken computer organization already, it keeps a trace of where the program is being executed. We won't go into depth, but let's say if this main function calls this foo function, and once we go into the foo function, a new frame is executed in the stack, which will have copies of like variables dependent on like which language we are using. So like some of the languages use call by reference, some use call by value. The values depend on like how the program is being executed in that language. So again, this foo function is calling the bar function. So bar will have its own uh, stack frame along with the variables. Another example is balance parentheses. So this is an algorithm, and how it works is initially we have a new stack. So this algorithm assumes that we have just one type of parentheses, which is just this um, parentheses, which is we are not talking about the other brackets like the box bracket or the curly braces. We don't care about these. We just care about the parentheses. So how it's going to work is you're going to have an empty stack. We are assuming that expression is balanced. Like initially we have this balance equal to true flag. We'll set the index to 0, which is now this is pointing to top, and we are going to continue like we have some expression, like let's call this expression 2 plus 3 divided by 5, something like this. So in this case, how the algorithm works is it gets the first character, it checks whether it's an opening parentheses. So if that's the case, it's going to push that into the stack. Next, it's going to go back to the loop. It's going to get the next character. It's going to check, like I'm on this statement. So it's going to check if the next character is a closing parentheses, but it's not a closing parentheses. So nothing happens. So basically it will only push the opening parentheses, any other character is ignored, and whenever we encounter a closing parentheses, it's going to pop the top of the stack to match the closing parentheses. So basically, like let's say if it is two opening parentheses, so it's going to, for the first iteration, it's going to push this opening. For the second one, it's going to push again another opening bracket. Now, if it's anything except opening or closing brackets, it's going to ignore and move to the next one. So it's going to move to the next one for 2 plus 3. And finally, when it sees the closing bracket, it's going to pop the element. So this is no longer there. Next, we have this divide. So nothing happens. Then we have 5, nothing happens. And then we have this closing bracket. So it's going to again do a pop operation. Now we are going to check if the stack at any particular point of time, like if we have a scenario where uh, we do not have elements on the stack and we are trying to pop, or if there are elements at the end of the algorithm that there's some opening bracket uh, that's remaining, which basically means that the stack is empty, is non-empty, then we are going to return false because we know that parentheses have not matched. So again, like let's say this parenthesis was not there. So in that case, we'll still have this one parenthesis on the stack. We are going to check if the stack is empty in this last case. So if this is not true, that means the parenthesis has not matched. Another example is the evaluation of expressions. So this is Dijkstra's two-stack algorithm. I'm going to discuss some of these algorithms in Monday's problem solving lecture because we are out of time and we want to discuss queues as well. So I'm going to discuss some of these expression evaluation algorithms in Monday's problem solving lecture. It can also be used to find palindrome, as we just saw in the earlier one. We were pushing all the values like till the half. In this case, this is another algorithm where we push all the elements onto the stack, like each character at a time. Like let's say it's mom. Then we are going to pop them off. So we have like MOM, but now it's reversed because once we pop it, we get the reverse as we discussed. And then we are going to compare two strings. Like that's another way to do the same problem. So in the next video, we are going to discuss queues as well as how we can implement the queues. But we are definitely going to see much more problems in the problem solving lecture. Thank you.